So what we're going to be doing today is called factoring. You may have heard that before. We're going to be factoring polynomials. So in the box we kind of have some vocab. So it says factoring polynomials using the GCF. We'll talk about what GCF is at the end of the box. And my screen's already dead, so, oh, thank you. You can give me the homework, you can just leave it on your table. Which is what we learned yesterday. A factor of a number is a number that divides another number evenly, so that there's no remainder. So, for example, the factors of 5 are 1 and 5, because those are the only two numbers that divide 5 evenly. 5 divided by 1 is 5. 5 divided by 5 is 1. The factors of 6 will be 1, 2, 3, and 6, because each of those divides 6 evenly. We don't get out any remainder. What we're going to be doing when we're factoring polynomials, we're going to find the greatest common factor, which in middle school you probably found the greatest common factor, but it was just a number. Now we're going to be finding greatest common factors that are monomials. Right? So we're going to kind of just build a difficulty through these examples, but this stuff is important to get down because it's building on what we did yesterday and what we'll do moving forward. All right? So first we're just going to practice reviewing finding greatest common factors of numbers. So there's two ways you can do it. You could just think, okay, what number goes into each evenly, or you can make a list. I like lists, so we're going to do that to start. The factors of 6, the numbers that divide 6 evenly are 1, 2, 3, and 6. When I divide them, they have no remainder. I get whole numbers out. The factors of 10, 1, 2, 5, and 10. It can't be anything greater than 10. It can't be anything less than 10. Well, it can't be anything less than 0 or less than 1. I want only whole numbers. So the greatest common factor is 2, because it's the largest, the greatest. Common, meaning it's the same between the two, and it's a factor. So our GCF, we would say, is just 2. All right, now if we do 12 and 16. Why am I writing GCF? Because that's our greatest common factor. What? Why are we doing a lesson? Again? We're not. This is the first time we've talked about it. 12 and 16. You think the factors of 12 are 1, 2, 3, 4, 6, and 12. And then the factors of 16 are 1, 2, 4, 8, and 16. So our greatest common factor, or our GCF, is 4. So what's the greatest common factor between 10 and 15? 5. So hopefully that seems like review, because you guys have found greatest common factors of numbers before. Now we're going to do it in this next row with variables. And there's an easy rule to follow when you're doing variables. So I'm going to write our rule in red. Your GCF is the lowest degree variable of whatever type it is. So in this case, to start, we're only going to be having one variable, so it would be the lowest degree x variable. So we have x to the first and x to the fourth. So the lowest degree, this is degree 1, and this is degree 4. So our lower degree is 1. So our greatest common factor between x and x to the fourth is x, the lowest power, x to the first. Yes. Why is it x? Because that's just the rule we follow. It's the lowest one. No, 1x is still right. We just don't write the 1 in front.
So for the next two,
Huh?
the next two are just x?
Well, no, because in example E, this is to the 4th degree, this is to the 7th degree. So we take the lowest degree term, which is 4, so our GCF is x to the 4th. Another way to think about this, factoring, kind of a synonym for factoring you may hear me use, is we say we pull out, all right? So what we're doing here is think, we have 4 x's here, 7 x's here. I'm going to try to pull out as many x's as I can until I have none left. From here, I could take 4 x's away and they'd be all gone. But I still have 3 x's left over here. If I was to take any more than 4 x's out, I'd be taking more away. I can't take away 5 x's because there's only 4 of them here. So that's why we take the lowest term. We try to take them all away until we can't anymore. So what's the greatest common factor of x to the 6th and x to the 9th?
6.
Not 6, but x to the 6th. You gotta have the x with it. So your GCF is x to the 6th. Because the 6th degree is smaller than the 9th degree. All right, next step. We're going to take these two ideas and I'll put them into doing it with polynomials. Now, I'm going to give you some steps that you can follow on your notes and on your homework as you're working through these. And we'll put them down as we go. Our first step is to find your greatest common factor. So my greatest common factor, I'm going to look, what's my greatest common factor between 2x and 10? What I do first is I first look at my numbers. What's my greatest common factor between 2 and 10? Well, that would be 2. The factors of 2 are 1 and 2. The factors of 10 are 1, 2, 5, and 10. Or 2. And now I look at my variables. Well, this term has an x, and this does not, so it cannot be a common factor. X is not a common factor between these two. It's only in one of the terms. So we can't take an x from both terms. So our greatest common factor is just the number 2. So that's your first step. Your second step, that you always do, is you are going to divide by whatever your greatest common factor is. So I'm going to write my original polynomial, 2x plus 10, and I'm going to divide each term by my greatest common factor. So I'm dividing this by 2, which is my GCF, and this by 2 as well. And then your...
Do you know where room 324 is?
324. So 3, and then you put it in factored form. We divide each by 2. We put our GCF in the front. So you write 2, and then parentheses. And then we divide each term by 2. So 2x divided by 2 is just an x. 10 divided by 2 is 5. So we do plus 5. This does? That? Because it is. You have great eyes. Plus 5.
I'm winning.
All right.
She's like, oh my gosh, you don't teach this and you take care of me. Use all words.
So let's do another example. We're just going to keep practicing these until they stick. We're actually going to skip B. B is a bad example. We're going to do C. So let's do our numbers first. What's the greatest common factor between 3 and 12? 3. 6 doesn't go, 3 goes into 6, but 6 doesn't go into 3. So 3 goes into both evenly. And then what's the greatest common factor between x cubed and x? No, you want to take the one with the smallest degree, so x to the first. So our GCF is 3x. We're going to rewrite our original, 3x to the third minus 12x. And then you're going to divide each side if it shows up. It will eventually. Beep, boop, beep, boop, beep. Our GCF. So we're dividing by 3x. And we're dividing by 3x. And then our last step is to write it in factored form. So we put our greatest common factor out in front. And then we fill in our parentheses with what we're dividing by. What's 3x to the third divided by 3x? Well, 3 divided by 3 is 1, so we're going to have a coefficient of 1. What do we do when we're dividing exponents? We subtract their powers. So we divide our big numbers and subtract our tiny numbers. So 3 divided by 3 is 1. 3, this is x to the first. So 3 minus 2, 3 minus 1 is 2. So we have x squared. And then 12 divided by 3, negative 12 divided by 3 is negative 4. And that's our answer written in factored form. No, I didn't.
Why is it 4 in the big?
Because the x divided by the x simplifies. There shouldn't be a big space. I made my parentheses too big. One thing that I want to point out now, if I was to redistribute this, look at what I get. I get 3x to the third minus 12x, which is our original. So factoring is the opposite of distributing. So to undo distributing, you factor. To undo factoring, you distribute. What's the point? Like I said, we're building towards a point. We're learning a bunch of individual things, how to do.
So there's going to be like a big
All right. Our greatest common factor . 2x to the fourth and 7x. The more chatting that's happening, the less work time you get. The longer it takes me to get through. So 2 and 7, the greatest common factor is 1. And then with x to the fourth and x, your greatest common factor is x. So altogether, your GCF is 1x. You rewrite out your original, 2x to the fourth plus 7x. And each term you're going to divide by your GCF. So I'm dividing this by 1x and this by 1x. And then I write it in factored form. So I put my greatest common factor out in front. I have parentheses. And then I go through and divide. I divide by big numbers. 2 divided by 1 is 2. I subtract my powers. 4 minus 1 is 3, so this is 2x to the third. Then I take 7x divided by 1x. 7 divided by 1 is 7. x divided by x simplifies to 1. So our final answer looks like this. Yeah. Because the greatest common factor between 2 and 7 is 1. Because the factors of 2 are 1 and 2. The factors of 7 are 1 and 7. All right. Let's flip to the back now. Now we're going to put this together with what we did yesterday. All right. So I'm going to go through and do all the same steps I was doing on the front page. First, I'm going to find my greatest common factor, which would be, again, this would just be an x or 1x, because this is a 1 up front. So the greatest common factor between 3 and 1 is 1. My lowest degree term is x to the first. So that's what I'm going to be divided by, or factoring out. I'm factoring out a 1x. That's what dividing by each term does. It factors it out. So I'm going to write x squared plus 3x is equal to 0. And then I divide each term by my GCF, 1x and 1x. So I write it in factored form if it loads. There we go, it came all at once. Give you a second to catch up. No. So I take this, I put my greatest common factor out in front. X squared divided by x is an x. 3x divided by 1x is 3. So it'll be plus 3. All right, this is I gotta plug this in. All right, so then we close our parentheses. And then this is still equal to 0. So what we can do from here is what we practiced yesterday. We can use our zero product property, or ZPP, and set both of our terms that are being multiplied equal to 0. So we did this yesterday. We said, well, this could be x is equal to 0, then also x plus 3 equal to 0. So one of our answers is x is equal to 0, and then the other one is x is equal to -3. So now we're just adding on to all the steps that we just learned, the steps that we learned yesterday. All right. So on the back side, I'm going to do every other. So we're actually going to do example C now. So we first have to find the greatest common factor. The greatest common factor between 8 and 24 is 8. It's the largest number that divides both evenly. And then I have an x squared and an x. I can take out just 1x. I can factor out or pull out 1x. And then I take my original and I divide each of them by, not 8, but 8x, because that's what my greatest common factor is. So now I write it in factored form, so it'll be 8x, parentheses, 8x squared divided by 8x. I divide 8 by 8, that gives me 1. I take x squared divided by x. I'm left with just 1x. And then I take -24x divided by 8x. That would give me -3. And then we still have this equal to 0 on the end. It'll catch up, don't worry. Or not. Or it'll just turn off. Let's see. So then we solve using our zero product property. We say 8x can equal 0. Or we could say x minus 3 is equal to 0. Using our zero product property. So x is equal to 0. Or x is equal to positive 3. Will be my two answers. All right, I'm going to do one more because then you'll still have 20 minutes to work, so it'll be fine. We're going to do example E. All right, so example E, what's my greatest common factor? It is a 3. What? 3x squared. So then I have to divide each of my terms by 3x squared. That's equal to 0. So we divide. So this is, we put our variable out of front. This is 1 plus, this would be 2, would be 3. All right, so an example like this, where we just don't have anything inside of our parentheses, 1 plus 3, we could just combine terms. So we get 3x squared, and that's 4 equal to 0. Well, then we can multiply, because then this is 12x squared equal to 0. Then if I solve, I know that x has to be 0. I didn't even have to use zero product property. I just know if I have 12 times x squared and I get to 0, the only thing that x can be is 0.